They can come after they've established their careers. Okay, so today we're going to talk about effective debugging. How many people like debugging? You like it? Okay. Well, yeah, no, actually, I hated debugging when I first started programming, but I was really bad at it. You do get better at it with practice. So, okay, so why are we going to talk about debugging in this tutorial? Okay, there are going to be bugs. The attitude you have to have in developing software, but really anything that's complicated, hardware, software, a mix, is that it doesn't work until you prove it works. Okay, that's the right mindset. When I first started developing things, my mindset is I wrote this, it should work. I no longer have that mindset. I wrote it, I'm sure it's broken. I now just need to go start finding the bugs. So consider it part of the process. And you're almost always right. Very occasionally it actually does work, but I can actually remember the number of times in my career where I wrote a bunch of software that actually worked, because I was so surprised, right? I had that attitude by that point of, it's broken, I just gotta go find the bugs, and I didn't find any, and that was the surprising thing. Debugging and testing take 50% or more of software development time, so it's a really important skill. You're gonna spend a lot of time debugging, and it's not just for software. So you say, I don't really like debugging that much. Well, you can't get away from it. If you're actually gonna be an engineer, nothing works the first try, you have to debug. So, I mean, I develop CAD tools in my research, but also develop computer chips. So those are the two things that I do, complicated software, but also computer chips. Trust me, computer chips are not easy to debug. If you take in your car, it's full of computers, mechanical components, it's a debugging problem. You know, a good mechanic is diagnosing what's wrong with it. If you're in communications, so say you go into communications engineering. So a new cell phone standard comes out, like 5G, huge amounts of money, actually many billions of dollars are spent buying spectrum and setting up base stations all over the place. And a lot of the computer chips that I designed actually go in base stations. So I know a reasonable amount about what happens when you set up a base station. You set up a new 5G network, your Rogers, and you have to actually test it and debug it. It's a very complicated debugging problem because you have new computer chips, you have base stations, you have antennas, you have communication protocols, you have cell phones. So people have to test this whole thing, and they have to test, you know, even are the waves being blocked by a building, or there's interference by some microwave tower nearby. It's a very complicated debugging problem, or maybe some of the hardware they got doesn't work properly. But it's always going to work it all out. So you need to have good debugging skills, kind of no matter what types of systems you go into designing. Okay, it's also a learned skill. So you get better at it with practice for a really long time. So good news, you're gonna get debugging practice in this course. So every time you have a bug, you're like, yes, I upgraded my skills. So you're not trying to put in the most bugs you possibly can, but you'll have some, and it's good for you to learn that. Complicated systems are hard to debug, they're hard to reason about, but they're not magic. They do follow rules. You can test them and gradually figure out what's going wrong. And debugging can be very rewarding. It is a creative pursuit where you like work out how to be a detective, how to be effective at figuring this out, and you find the root cause and you fix it. And it's a valuable skill. So one of the most kind of difficult debugging stories that I have, so actually one aside, one of my favorite questions that I ask grad students when I'm interviewing them, and I asked engineers when I was hiring them at my startup and then at Altera, was tell me about a difficult debugging problem you have. Because I want to see that they had a difficult debugging problem and they actually were creative or systematic in how they approached it. If they actually didn't have a very good debugging story, it's like they couldn't think of anything difficult they'd ever debugged. That's not great. It tells me they probably never designed anything difficult, or they asked the person next to them to, how do you fix this? Which is not a skill that you can use in industry. So yeah, it's important enough that I would check it in interviews and still check it in interviews. One of the interns that I had at Altera, is a U of T student, ECE, and Henry Wong, later became my PhD student here, is a brilliant engineer, but the thing I most remember about his internship at Altera is we had a very difficult debugging problem. Northern Telecom at the time was a major customer, tens of millions of dollars of chips a year they would buy from us. And they had a major design to go into one of those next generation communication systems where those systems use a lot of FPGAs, so they were compiling their design into one of our FPGAs. And Cordis, the CAD system that I was one of the main architects of, kept crashing. And it was crashing in the placement engine, which chooses where everything goes, which is my problem, okay? So, and this was getting a lot of profile. They're phoning up, their CEO is phoning up our CEO and complaining. And so I'm getting communication from the CEO, what's going on with this bug? So it's a fairly high pressure bug. And it was a weird one. Basically, we had code that would check that the data structures were consistent as we were optimizing, and that code was flagging inconsistencies, and my philosophy was kill the program if you find an inconsistency, because I do not want to generate incorrect hardware, because that's even worse. Now we put incorrect hardware in some system, who knows what happens. So that was happening, but it wasn't happening all the time. 80% of the time, the program would crash at some point, sometimes after 10 minutes, sometimes after 2 hours, other times it would finish. So it was baffling. I had my team look into it. I looked into the logs, and I told my boss, this is so strange, I think it might be a hardware fault. And he basically said, it's never a hardware fault. You know that, it's the software. You gotta fix the software. And then Henry, my intern, basically put code into the program that whenever these checks were gonna fail, he flushed the cache. Have you guys heard about caches yet in 243? He'd flush the caches with really low-level instructions, reload all the data he was depending on, recompute it, and try again, and he'd log an error. Once he did that, the program completed, and it logged a bunch of errors. So he traced those down and basically said, the processor you're using, which is a certain Intel processor, has a bug in its memory controller. You're failing at these points to read memory correctly, and he showed them where the patch was. There was a firmware patch to upgrade it. Anyway, so then they fixed it, and they were really happy. I was actually very tempted to tell my boss, I told you it was a hardware problem, but I resisted the urge because I thought, this is like a communication challenge. Like you can sort of visualize how does that conversation go, and you go, it doesn't go anywhere good. So I'm just not gonna say that. I'm just gonna think it, I'm gonna tell my wife. Anyway, after that debugging problem, which was quite amazing because he couldn't access the servers at Nortel or anything, but he debugged their hardware through a very complicated program. One of the directors in San Jose sent me an email saying, make Henry Wong an immediate permanent job offer. So that's how important being able to debug really difficult things is. Henry is a brilliant engineer. He works at Intel developing their next generation x86 processor. So that's now his job, is to make the next processor. So anyway, why am I telling you that long story? Because being really good at debugging, these are some of my favorite technical stories, like the really hard problems that someone was able to figure out. And if you get really good at that, it's very valuable. Okay, so what are we gonna talk about today? A systematic approach to debugging. So 3 kind of high-level approaches that are really just a mindset. Then we're gonna do a hands-on debugging demo where I'm gonna debug one of the milestone 1 functions, the one we actually wrote last week, so that you can see exactly how do you debug things in this course in particular. And then with the remaining time, you can debug a smaller program in one of those online IDEs. Okay, so 3 high-level models that I find useful to keep in mind. One is the infection model. So software systems, like most systems, maybe all systems, are causal, right? So later events depend on earlier events. So you can think of that as my program state is all sorts of variables. And I started, at some point in time, my program was working okay. My program state was correct, but I have some bug in my program, and at some point in time, I go through that buggy code and I corrupt the memory, right? I've got an incorrect state. There's a variable that's got the wrong value. Now, if you're lucky, you crash right away, right? Or you generate an incorrect output right away, because it's easier to debug that, right? Right when you made the mistake, you get some output that tells you it's a mistake. But often you don't get that output right away. The program's made a mistake, but it's not visible. But that buggy variable, that wrong variable, now goes and results in other variables being incorrect as more of the program executes. And at some point, we actually observe the failure. So maybe the program crashes, maybe it generates an incorrect output. But we basically have to keep in mind that it might not, the root cause might be further back in time. So we may have to backtrack. And you want to think about how to do that efficiently and systematically. Okay, so that's one thing to keep in mind. This infection model of corruption is spreading throughout our program. Another approach to keep in mind is called the wolf fence algorithm. So the idea is if I was trying to find a wolf in Alaska, and I can only do 2 things. I can listen, and I can build fences. Okay, so I can build a fence that divides Alaska in half. I can listen and see if the wolf is on the left half or the right half. Gives me some information. I can build another fence, do the same thing. Now I see bottom or top, and I keep doing this. And I'm basically dividing up the state, figuring out eventually a very small region that I should go search for the wolf. Okay, so we do the same thing with bugs. We can systematically try to eliminate large parts of the program from consideration, trying to zoom in on what parts we really analyze in detail. So this is just kind of a visualization of that. So I've got all these variables, that's my program state, and they're changing over time. So my program's executing and they're getting updated. So there's a lot of potential root causes. We could corrupt these one of many variables at one of many points in time. So that infection model says, well, I observe a failure here, but that might not be my root cause. So what you're trying to do is figure out ways to systematically eliminate possibilities as fast as you can. So you're trying to be efficient. Some things are more likely than others, some things are easier to do than others. You take that into consideration as you're trying to eliminate possibilities. So, for example, I might have the ability, maybe I have an earlier check that checks whether all my variables are correct to this point, or maybe I go in and just inspect them. But I can check, is everything okay at this point? And if it is, I can basically, maybe this is at the end of the load map, for example. So I can check whether my load map loaded the data correctly. And if it did, I can say, I don't want to look at any code that came before this. It's all good. I can also say, well, I got a failure here. And it only looks, the code that generates this output only looks at a few variables. Maybe it looks at one global variable, maybe it looks at two global variables. And nothing else. Two global variables, a couple local variables. I can eliminate everything else, right? So maybe I got a bunch of other state in my program, but it's not going to affect my output, so it's gone too. So I'm kind of applying the wolf fence method to narrow down what do I have to look at. And then I can choose to backtrack. So I can say, okay, well, I've got a failure here. I should look at the code right around there that generates that output. And I look at it, and it looks correct. I don't see a problem. So I look at, well, let's look at the inputs to that function. Maybe they were wrong. So I backtrack and I look at these inputs, and that one looks okay. These inputs are already validated. They're okay. So this one should be my problem. I look really closely at the code that generates that variable, and I find my bug. Okay, so this is graphical, but it's like a mindset. How can I cut off large parts of the program from consideration quickly? How do I backtrack from the observed error to possible places where it could have been created? Okay, the third thing I want you to keep in mind is that you're a detective, or you can think of it as the scientific method. So you're going to go through this cycle many times. You're going to observe that there's a failure. You're going to basically look at the information you have about the failure. You're going to form a hypothesis. Okay, what could cause that failure, right? So my program crashed. And I think it might be because I'm going out of bounds of a certain array. You predict what would happen. Okay, so if I'm going outside the bounds of, say, a street segments array, well, I've got a loop that goes with a variable I. It should go past the end of this array at some point. So I should now do an experiment to see, is that it? So I could run, and you think of how can I do that experiment quickly? So I could run this in the debugger, and I could watch what that variable I goes through by single stepping, or if it goes to a very high values, I might set what's called a conditional breakpoint, a breakpoint that'll fire if that I variable ever becomes equal to greater than some number. So I quickly can check, well, is that what happened? And that's part of where the debugger comes in. The debugger makes it faster to check hypotheses, faster to make observations. If my hypothesis is proven, I've found the bug. If my hypothesis is not proven, I got to try somewhere else. But I've also eliminated something from contention. So again, it's like a detective. You'd like to prove this is the villain, but there's also value to basically showing the following person has an alibi, and I don't want to consider him anymore. Okay, so those are kind of high-level approaches to keep in mind. Now we're going to get very hands-on. So we're going to take the function that we wrote last week, which again was, we have this intersection, there's a certain ID, and we have a function that we have to write called find street segments of intersection. We pass in the ID of an intersection, and we're supposed to return a vector that gives the IDs of the street segments that are connected to it. Okay, so in this case, we return a vector with these three numbers in it. Is everybody with me so far? You remember this? Okay, so it's good. Your cache is at least a week large. That's good news. Okay, so we already wrote this, and we wrote it to make it fast. To make it fast, we created a global variable, and our global variable was a vector of vectors, which is a lot like a two-dimensional array. We gave it a nice long name because it's a global variable. So we call it intersection street segments. Okay, and just to visualize how this lays out in memory, the first dimension, the first vector, we're going to index by intersection ID. Okay, so it's going to be a pretty long vector from 0 to about 190,000. And every entry in that first vector is itself a whole vector. Okay, and that whole vector stores some number of integers. So for that, for an intersection that had 3 street segments that hit it, I'm going to have 3 integers that are the 3 IDs. Maybe this next intersection one might have 5 street segments, so it has 5 IDs, and so on. So if I basically, let's see if I can write on this properly. If I basically go, whoops. Okay, so if I wrote this code, intersection street segments, maybe I should have chosen shorter names for the tutorial. So intersection street segments of 1, what is that going to give me? Just to see if you're understanding this data structure. So I said index 1 of intersection street segments. What does that refer to? What do you think? Yeah, it's this whole vector. Okay, so like this whole thing, the whole vector. Okay, and if I say intersection street segments of 1 bracket, sorry for the messiness, 1, 2, what does that refer to? What do you think? Right, so it goes 0, 1, 2, that one. Okay? Oh, okay. Oh, interesting. Okay, so that's how you do that. Thank you. It's good that I'm capturing it on Zoom as well. It's like the screen recording. Okay, so you guys understand how this works. And it does behave a lot like a 2D array with kind of sort of ragged edges. Like it can be a more regular shape. Okay, so you don't have to memorize this code. I'm just showing you the code that we had for this function. So we have this global variable, and most of our complexity now is in the load function. So we have a helper function called load intersection street segments. I'm going to show you in a minute in an IDE. We call this from load map. What do? We get the number of intersections, calling that low-level API. We basically push back an empty street segment ID vector. Okay, so that's what we're doing there into our global variable. And then we got a big loop that goes through all the intersections and loads up this 2D vector. Okay, so from intersection 0 to the number of intersections minus 1, we say tell me how many street segments intersect that intersection, and then for each one of those street segments, let's go get its ID, that's SSID, and let's push it back into the vector, the appropriate vector. Okay, so we're doing this for intersection 0, we're going to ask what are all the street segments connected to it, and we're going to push it into vector index 0. Does it make sense? So the overall idea is clear here. Okay, so most of our complexity is in load map now to make this fast, and our actual function that returns the street segments of intersection is really simple, right? It gets an intersection ID, and all it does is it returns a whole vector, and the whole vector it returns is just a vector for that intersection. Okay, so everybody basically with me with this code? As long as you get the basic idea, it's fine. I understand it's hard to fully understand code when somebody just shows it to you on a screen. Okay, so I'm going to switch out of this. I'm going to show, basically going to go onto the UG machines and actually do the debugging. Okay, let's hide these. Okay, so, and I'm gonna do this in somewhat painful detail, just so that you can see exactly how you debug something in this project. If I'm going too fast, tell me. If I'm going too slow, tell me. Like if you're just like, I can't take it anymore, he's gotta go faster, let me know. Let's see if I can make this bigger. Huh, it's odd. All right, let's try this. You guys see that okay? That's visible? Okay, so to start, I'm gonna start, how many people are using Visual Studio? How many people are using NetBeans? How many are using C-Line? So that's Visual Studio. How many people are using Visual Studio Code? Okay, how many people are using NetBeans? Okay, how many people are using C-Line? Okay, how many people are using like Eclipse? That's the last IDE. Okay, how many people are just using command line tools and so on? Okay, and then a few of you are using nothing. So you're using the force, right? You're trying to control this program with the power of your mind. So we'll probably want to use one of these. Okay, so it looks like VS Code's the dominant one. So I'm going to do this in VS Code. It is interesting. Every single IDE appears to have certain quirks. So we used to use NetBeans as the dominant IDE in this. It has a few quirks that were a bit annoying. So we switched to VS Code because students tend to know it better. And it also has some quirks that are really annoying. So you're gonna, I may hit a few of those here. C-Line might have the fewest quirks so far, but basically it does seem every IDE has some weird quirks. So I don't know how to get away from that. Okay, so this is, if I do an ls here, you'll see that this is kind of my main, like the root of my project. Where you see the make file, that is where your mapper is. Okay, that's where like the start of your project is, the root of the directory. VS Code is happier if you start from that directory. So I'm typing code space dot, which means start in this directory. Why do I do that? It helps VS Code find the make file. We find that one of VS Code's quirks is if you don't do that, it may not find the make file well. So do it that way. Okay, so now I've got VS Code open. Let's see if I can zoom in on this. Okay, good. And let's get this welcome screen. And let's open up the code. Let's go. Okay, so is this big enough? Is this size okay to see or not? Good? Can you see it okay? All right. So here's our directory structure. So we have a folder called main/source. It does have a main.cpp in it, but we're not going to do anything with this for this milestone. So if you're in there writing stuff in main.cpp, I mean, you're allowed to do it, you know, if it's helpful to you for testing things, but it's not going to affect what you get in this milestone. It's not going to affect any of our tests. So don't write your code in there. Your code is going to be in libstreetmap. Under libstreetmap, there's source, and we gave you the skeleton, we'll get rid of this, of a CPP, m1.cpp. But you can make as many files as you want. So anything you put in m1, a libstreetmap source, and any subdirectories will automatically compile. Okay, so you make many files, even subdirectories as you like. And I might have to make this a little smaller. Let's see. Let's see if I can make this. All right, that's a bit better. So let's just look at what we have in here. So there's a copyright header. So I'm going to show you what's in this file. It's not a lot. The first thing is I have a global variable. Remember, for speed, we made this global variable called intersection street segments. Global variables are important. They should not have short names because you don't want them to conflict with things. They should have comments. Okay, so notice I have a comment here saying, here are all my global variables, and I say we're only going to load them in load map. We'll clean them up, we'll clear them in close map, etc. You should have that too. Your TA will not be happy with your style if you have global variables called like F1 and F2, and you don't have comments. I have some helper functions. Well, exactly one helper function right now. So a helper function that I only use in this file, I can just declare at the top of the file. That's what I've done. And I've made a little banner saying, here are my helper function declarations. And they made another little banner saying, here are my definitions, like the actual body of the functions. So style matters. We'll talk about style more next week, but try to organize your program, not just write it for correctness. Okay, here's my load map. We pass you a string, that's the name of the map you're going to open.
Load map always has to load in data for our lower level APIs, or else you can't call them. So I do that. And then load map can get long. You're going to load a bunch of data structures in load map. So if you just start writing all your code in load map, it's going to get long. Your TA will be sad. Your TA will deal with that sadness by deducting marks, right? Doesn't make TA happy, but it kind of soothes the TA a little bit. Don't do it. Don't put like long, don't make this function really long. The way you don't make it really long, make helper functions. And your load map will look clean. You're going to see a bunch of helper functions called with nice names. All the real work is in your helper function. Okay, so here's my helper function. Load intersection street segments. Let's see if I've written a comment on this actually. Okay, so I would lose some marks if I didn't put a comment on what this function does. So I should have put a comment here where I declared it of what this does, but I didn't, so should have done that. Let's look at what this function does. Basically, I already showed you the code. Get the number of intersections, go through all those intersections, and basically load up that global variable. So like I said, I won't go through that again. Here's my function that actually uses that data. So find street segment of intersection, so it's what I showed you. And that's all I've written so far. So every other function that we have to write for M1, I've just stubbed out. Okay, we talked about that last week, but basically stubbed out means simplest body of the function I can think of. If it's supposed to return a double, I return 0. It's supposed to return a vector, I return an empty vector. Not going to pass any tests, but it'll compile. So, and I've got that for all of these. Okay, so I could do this from inside the IDE, but I prefer when I'm just compiling and checking stuff. I usually do it from the command line. So you could do it either way. But I'm just going to build this. Okay, so I made the program. By default, it makes the release build, which is good for speed testing. I'm feeling optimistic. I think maybe it'll work. So I'm just going to run it and we'll see what happens. So ece297 exercise, we also have to say which milestone number, so 1. And it's going to run a bunch of suites of tests. And it doesn't look good. Looks like I'm getting failures all over the place. I hit Control-C to stop. I could scroll back to look way back at the start of the errors, but what I'm going to do is I'm going to make this go one screenful at a time. Have you guys seen like what I just, do you know what I just did? I put a vertical bar and then more. Does everybody know what that does? Okay, so in Linux and all variations of Unix, vertical bar is a pipe symbol and a command prompt. It means take the output of this program, send it to the input of that program. So what I've said is take the output that comes out of ece297 exercise, and instead of just drawing it on the screen, send it to a program called more. More is a Linux utility that shows things one screenful at a time. So if I hit enter now, it's going to do the same thing, but you see that instead of just scrolling past, it shows me one screenful and then it says more. And this is nicer for me. I don't have to go scroll way back. Okay, so I can look at this. It's going to run 11 testers. It's running the first one, which is for functionality of intersections. And it basically tells me where the actual test is. So you can actually go look at this test, right? That's a public directory. And it says on line 47, there's an error. And the error is an unhandled exception, test crashed. What do you think that means? You will probably get this error message. So unhandled exception, what does that mean? The program went crazy, okay? It's been killed by the operating system. So something quite bad has happened. The most common thing is you've actually got a seg fault, but it also could be a divide by 0 or something like that. So you've done something quite bad. It doesn't even complete. It's been killed, okay? So I got a bad bug. This streets database is already loaded, just means that I asked to load in the data for our API and it was already loaded. I'm not super worried about that right now because I got a crash. So maybe that's why that happened, but I'm not gonna worry about this right now. Okay, and then it tells me that there's another, when it gets to line 169 of that same test, there's a failure in a function, in a test called directly connected. And it basically is calling intersections are directly connected. If I hit the space bar, I get the next screenful. So I just hit the space bar. And it's basically telling me over and over again that a whole bunch of tests on a bunch of lines are failing is directly connected, or intersections are directly connected. And it's basically telling me like, I was saying false when it should have been true. Okay, this is a different function, right? There's a function called intersections are directly connected that I'm supposed to write. It's failing its test too. It's not actually crashing, it's just failing. I always return false. Like I stubbed this out. So I don't expect this to work. I don't pay any attention to these error messages. The error message I want to pay attention to was that first one, right? This is the test that I was actually hoping to pass. And if I didn't know the details of this test, as I said, I could just open up that file to look at that line, what exact function are you testing? Okay, so test crashed. What do you think I should do next? Sorry, go ahead. So debug, so I could fire up the debugger, and that's a very reasonable thing to do. We have some other tools though. So you're always trying, and that's not a bad idea. So it depends on the person. The person might say, I'm immediately going to fire up the debugger. I'm not going to do that first, because you're always trying to get the most information for the least effort. That's what makes you more productive at this. So is there anything I can do that might be less effort, than lazy, right? Than firing up the debugger and looking at stuff. What do you think?
You can look at the test that was run and you can
I could do that, so I could go look at that, but that sounds like maybe even more work, right? So I don't think you guys understand the depth of my laziness. So yeah. Right, so I could run Valgrind. Maybe Valgrind will just tell me exactly where the bug is, right? So that might be good, especially an unhandled exception. Well, that sounds like, that's often a site fault, kind of things that Valgrind's good at. Or I could run the debug check build, right? I'm actually going to run both. So I'm going to run the debug check build first. So let's see how I do that. Well, actually, how do I run the debug check build? What do I do? So it's a skill testing question. You might not remember. If you don't remember, it's fine. I'm going to show you how. So do anybody remember how to do it? So debug check's really easy. All I do is I rebuild the program with configuration debug check. Okay, so make debugs it. I can also do this from inside the IDE. I'm going to do it from the command line. All right, so I just rebuilt the program, and I changed the compiler options. It's put all sorts of extra checking in, and now I just rerun ece297 exercise. Okay, so I'm going to run it again. It's slower. Okay, so debug check is slower, so this is going to take a little longer. But it now got far enough, and basically I only want the first check. So I hit Control-C to stop it. Okay, so it's running that test of the intersections, and it's basically, debug check kills your program when it finds a problem. So it actually killed this whole test as soon as it found the problem, but then there are more tests. So ece297 exercise is going to keep running. So I killed it. Okay, what does this tell me? It tells me I'm on line 427 of something in the vector of standard library. Okay, I don't really know exactly what code this is, except I can tell it's in vector and it says it's operator square bracket. Okay, the rest of this I don't really care about. So the bug is probably not in the standard library, but it's telling me you are in vector using the square bracket operator. And what you were trying to do was trying to subscript the container, okay, square bracket operator, with an out-of-bound index. So I was trying to use index 1, and this only has one element. So for a vector with one element, there's only one legal index, and it's 0. Can't use index 1. So, okay, so I actually gained, that didn't take me long, right? And I gained a fair amount of knowledge. It's a vector. I'm trying to access entry 1, and it's only got one entry. So if I can find that vector where I'm accessing it, I can fix the bug. And it gives me a little more information, like where is this in memory, but I'm not going to do anything with that, right? I could try to use that in the debugger, but I'm lazy. I'm not going to do that. Okay, so next thing I'm going to do is I'm going to run Valgrind, because Valgrind gives related but somewhat different messages. Maybe it'll give me some additional information, and that should be pretty easy too. To run, well, let me show you one other thing. As I'm running this, I might get tired of running all these tests over and over again. Like I've got all these tests running, and I know I'm working on just the intersection tests. There are 10 more sets of tests that I have no hope of passing and I don't care about. So all the tools we give you in this course have a help parameter, -h. So if I type ece297 exercise -h, you get the help screen for exercise. All right, and what it's telling you, everything, this is standard notation for programs describing how to call them. Anything in square brackets is optional. Anything not in square brackets is mandatory. So this basically says you use this, you type ece297 exercise, you must give a milestone number. It's not in brackets, but then you have these optional arguments. And down here it says what those are. Okay, so -H means give help. -- list testers will tell you the names of all the test suites that are going to be run. And -- run tester, and you give it the name of one of those suites, will just run that one suite. Okay, so if I want to just run one set of tests, which is what I want to do from now on, I can use this. So there's also, well, let me show you that run. So I'm going to do ece297 exercise 1 -- list testers. Okay, so it told me all their names. You guys know you can use the up and down arrows on a command prompt. Do you guys know this to avoid typing? Okay, so I just use the up arrow, and I'm going to just go edit this. It was run tester, and I need the name. So I could take this whole name, right? Copy it and paste it in. Actually, maybe I will do that just to do it once. So I'll take this whole name and paste it in. Okay, and now I'm going to run just this one test. Still debug check, so it's still going to be a bit slow, but it should crash just the way it did before, but now no other test should run. After it crashes, yeah, so it crashes and it basically stopped right away. There are no other tests to run. So this is a bit more convenient. This is the way I'm going to do it from now on. And also debug check, yeah, the test told me that this is probably due to memory corruption. They said and that makes sense because the debug check build told me I'm accessing a vector out of bounds. So everything's kind of lining up. Okay, so next thing I want to do is I want to run valgrind. Running the command line to run valgrind properly is a bit complicated. So what we're going to do, and I actually want to run valgrind on the actual test, right, which is often a shared directory. ece297 exercise is basically compiling our unit tests, linking them to your library and running them. So to make it easy for you to run those tests and debug them, we basically have an option debug tester. Okay, and it works the same way. I have to give it the name of a test. So I'm going to paste in the name of that test again. This is not magic at all. All it's doing is it's grabbing that source code that you could go grab yourself, sticking it inside your project so that you can compile and build, and now you'll be running that exact test. And you'll be running it where the source code for the test and only that test is actually inside your project. So it's just easier to work with. Does that make sense? So I run that command. Okay, and what does it say it did? It basically says that if there are any tests already in your program, it's backed them up to old tests. And we put all these tests under a different directory. So under libstreetmap, not source, libstreetmap/tests, that's where we put these tests, okay? So you can keep track of, this isn't code that you wrote, it's code we wrote. In case you put some of your own tests in there, before we copy these ones in, we back up the old ones, just in case, you're like, oh no, you sort of wrote my own tests. Okay, so then it gives you some information. So it says to recompile it, you can go into the IDE, and you should build what are called unit test configurations. So different configurations of your program. And it also tells us how to run valgrind. So to run valgrind, first I'm going to make sure that I built the program. Well, actually, I'm going to do this again. Okay, well, make conf equals debug test, because this will be a debug check. All right, so I built the program again, and I'm going to go back and look at that text. All right, so basically this --debug tester did a bunch of work for me. Copied over the test that I wanted, and it told me what I should do next if I want to debug it, and it told me how to run valgrind. Okay, so I'm going to copy this whole command line that it printed out is how I can run valgrind. Okay, so I'm going to copy that. How I can run valgrind on that one test. So you'll notice that ec297 exercise already runs valgrind, but it runs it on a really small test in St. Helena. Okay, I don't want to run that one right now. I want to run the exact one that was crashing for me. this command line will do that. So I'm going to go down here, and I just paste this command line in. Okay, so as soon as I hit enter, it's going to start running valgrind. So there we go. And actually, I'm going to tell you a couple things. All right, first, let's look at this command line. It's pretty long. You don't really need to understand it all, but you might be curious, why is this such a long command line? Okay, so the first part of it is, actually that's not the command line, this is the start. Okay, so the first thing is we just have the full path to where valgrind is. So it's in a directory called user bin, it's named valgrind, so that just starts the program. Valgrind takes some command line options. So valgrind actually has multiple tools inside of it, they can check different things. So we say we want the memory checking tool, and we also tell it that we want you to check for memory leaks. Do you think the crash I have is due to a memory leak? What do you think? Yes, no? You look like you're shaking your head. Think, no, it's not a memory leak? It's not a memory leak, okay? So memory leaks are not as dangerous. They're kind of poor practice, and if you leak a lot of memory, it could cause a problem. But this is worse. This is memory corruption. So maybe I don't care about turning on all this memory leak stuff, but I don't really, it's okay. I'll leave it on. So that's what all that is. And then this -- suppressions. Okay, it turns out there are some memory leaks, very small memory leaks in some standard libraries for C and C++. Okay, there are only a few, they're not very many bytes, they don't really amount to much, but you can't fix them. And valgrind will flag them. So you'll wind up with a bunch of memory leaks and you'll say, what are these? You'll post on Piazza, everyone will be wasting time. So what we do is we make what's called a suppression file. So we've made 2 suppression files to suppress different groups of memory leaks that you cannot get rid of. So you just will never see them. Okay, it's a standard with checking tools like valgrind. You can make suppression files to say, I know about this one, I'm okay with it, stop telling me. And then the very last argument here, testlibstreetmap, is the name of the program that we're running valgrind on. Notice this is not mapper. Your main executable for your project is going to be called mapper. That's the main program an end user runs. Testlibstreetmap is the executable that has been built for this unit test. That's what we want to run valgrind on in this case. Make sense? Okay, so that's what that command line's doing. Okay, so I typed that command line, and then I got this. Okay, it says memcheck, valgrind, that all sounds good, running on testlibstreetmap, and then it says asan runtime does not come first, and then it doesn't do anything. Okay, so that message is kind of cryptic. asan is address sanitizers. It is part of the debug check build. This is telling me something that you probably already know because you saw it in milestone 0, but you might have forgotten. Valgrind and the debug check are incompatible. So I know what to do. I have to rebuild this in debug, right? It doesn't really make sense to run valgrind on top of the debug check build, and it also doesn't work. So you get that message, you say, I forgot to rebuild. I'll rebuild it. Now it's good that I can just press the up arrows because I don't have to type this long command line again. I just do this, okay? And valgrind is going to also slow my program down, so this is going to take a minute. So any questions so far? We did have awkward silence or a really good question. So yeah. So when I did debug tester, it prints that command line. So debug tester does a few things for you. It copies the test over from our shared directory into your project. And then it tells you, here's what you need to do to debug, and it says, here's what you need to do if you want to run valgrind. And this is an example of how you want to make your software infrastructure good. Before that, what we had was some instructions that students would always justifiably get confused about, post on Piazza, and I would spend my Saturday afternoons typing the same instructions over and over again. So then we put it in a program, and then it does it automatically. So every time you kind of find, it's good as a programmer to be lazy, right? I gotta answer this question over and over again. I can write it in the script. So that's why debugging tester exists. Yeah. Yeah, so Visual Studio, the command terminal it shows is the same as the terminal I'm using. Like it's just, I find like using a little window in Visual Studio to only just using a window I want. But all the commands I've shown you, if you like, Just typing them in the command line, and the studio will all do the same. So, okay, so this is completed. Now, one annoying thing is it generated all sorts of output that I have to scroll back and look at. Okay, so I'm going to try running this again. And let's do this. This time, I'm going to use my pipe symbol, and I'm going to send it back into that more program again, so I can see it one screenful at a time. I just want to look at the first couple errors. I probably don't want to look at them all. I put this funny ampersand on because I actually wanted to take not just the regular output from my program, but also the error output and send it all to this more program. Okay, so I'm going to run this, and if I typed it correctly, it's going to do it now one screenful at a time, which will be nicer. And if I didn't do it correctly, I'm just going to scroll way back up. So the ability to pipe things between programs is quite a useful feature that like people who work with Linux a lot get used to, right? So there are a lot of utilities on Linux to do searching and show things one screen at a time and stuff. So they're pretty handy. All right, so this takes a while, and eventually it should get to where the error is, which I will now hopefully get one screen at a time. Okay, so and it worked. Okay, so I've got my first error, and you can see I've got the little more thing in the bottom left again, so I'm getting it one screenful at a time. So let's look at this error. So, and actually I might just make this, these lines are so long that it's probably better if I shrink the font a bit so you can see more of it. If you're in one of the lab workstations, let's see if I can make this, I won't reformat. Okay, I guess I won't bother. I'm gonna run it one more time, I can't help myself. All right, so let's try that one more time, but this time with kind of a wider or smaller font. Because the outbound output lines are really long. So if you have them all wrapping on top of each other, it's kind of hard to read. So I'll make the font bigger again in a minute. Okay, so this is going to take a minute to run again. So any other questions while we're waiting? So in your own project, you will get fast at this. You'll be able to do this a lot faster. I'm doing it very slowly so you can kind of hopefully remember all the commands and so on. Okay, so we're back to the error. So this is the first thing that it said, right? You know, it said it's running libstreet, test libstreet map. This is the first error, invalid read of size 8. What does that mean? So, okay, so we already got from the debug check build that it said we're accessing a vector out of bounds, right? It's got one entry and we actually tried to get to index 1. This is saying we have an invalid read of size 8. Does that sound like it could be the same thing? Right, so going out of the bounds of a vector is going to cause invalid reads or invalid writes. It says it's an invalid read. Size 8 just means 8 bytes. That doesn't tell me much, okay? So I look at it, gives me a call stack. Where did it happen? So it basically happened in pushback for a vector. So this is a vector again, it's in pushback. Where was it called? Line 65 of load intersection street segments, and that was called by load map. And then you'll see a bunch of other functions, like suite intersection queries. These are our tests. I'm going to show you what the test looks like in a minute, but basically the unit tests have a whole bunch of functions that gradually build up the test and then call you. So you don't care about any of this, right? What you care about is load map called load intersection street segments, and line 65 of that called pushback, and that was bad, okay? So I can go look at that. I should go look at that. So let me bring up Visual Studio. And if I go look at line 65, it's right there. So let's see if I can get rid of this. Okay, so line 65 is this one. Intersection, street segments of intersection. Okay, that pushback, that's the bad line. Okay, so I know a lot now. Maybe I look at this line and the code around it really carefully and I find the bug. but maybe not. So I'm going to say I don't find it. I don't know what to do yet. I'm looking at this a little more. There's a little more information it gives you. So I don't care about the rest of this call stack. There's a whole bunch of stuff here that's all in our unit test. Don't worry about that. There is, let's see. This line is another piece of information. Okay, so it's telling me that the memory I was trying to read is shortly after another block of memory that I actually did create with new. And where was that memory? So basically it's telling me this because it's saying maybe this is what you were trying to read, because this is kind of the nearest legal thing near where you were reading. So maybe this is not what you were trying to read, but maybe it is. Okay, so it tells me it was created by new. That was created by something that a standard library function called allocator. Okay, I don't care about those. I didn't write those. I keep going back. You keep going back till you get to something you recognize. And it basically says, well, you're in vector. Okay, so I'm inside STL vector. And how did I get there? I was called from line 58 of m1.cpp. And that's in load intersection street segments. Okay, so I go here and look at line 58. And it basically says, what I was trying to read, well, there's some memory that was created here, and that's close to what you just wanted the bounds on. Okay, that kind of lines up with my problem is intersection street segments. It doesn't tell me that much more. My real, like the bug, the final evidence of the bug is this line. Okay, that's what's going wrong. And the nearest legal memory is in this intersection street segments, which kind of makes sense. That's what I'm actually saying. But maybe I still don't know what to do. So I might look at this code really carefully now and I might find it. But maybe I still don't know what's going on. Okay, so what do you think I should do next? You said it earlier. You said run the debugger. So now where you run the debugger. You can look at the code, don't see it, you're going to run the debugger. So what I'm going to do is let's take like a break till, I don't know, 4:12, and then we'll start running the debugger. So, okay? Okay, so I lied that we started at 4:12, we went to 4:15. So we'll get going again. Hopefully, is this big enough? Can everybody see the font here? Is this fine? Try to balance between showing you enough code and showing it big enough. So can you read this? What do you think? I'm going to take that as yes, you can read it. Okay, so I already showed you your code that you write for this milestone is libstreetmap source. We have this m1.cpp file. Now I'm going to go in the test file. Okay, so we give you a couple of just skeleton tests in your project. So those have been moved into old tests. They don't do anything very useful. And because I ran that debug tester, whoops, let's get rid of this. Okay, because I ran that -- debug tester option, I now have some actual tests in here that do something useful. And so what have I got? The first thing, here, let me make this a little bigger. Okay, the first thing is this, it's all in libstreetmap/tests. There's a test driver. Test driver is very simple. Okay, I'm going to go over unit tests next week, but we're using a unit test library, provides a whole bunch of utilities. One of those utilities is we can call this function run all tests. It just ran all the tests, and then it basically returns. This is the main function, by the way. Okay, so this is the main function of test libstreetmap. That's where this is going to start running. It's not your main, it's a new main. And all it does is call this function, which will run all the tests. And then you can actually return numbers to the operating system. So this returns the number of failures out to the command prompt. That means if I was actually writing scripts, like ece297 exercise, I can look at that number to see if you had failures. That's actually part of how ece297 exercise reports failures to you. It actually grabs that number when this program exits. Okay, there's this unit test util.h file. This is a bunch of utilities we've written for ourselves to make it easier to write unit tests for this course. You don't need to look at it, okay? It's all, you can if you want, but it's all basically just helper functions that we use. The actual test is here, and it's the test I asked for. Remember, I asked for the public intersection functional intersection Toronto tests. So that's what I asked for. That's what I've got. Okay. So I'm going to go look at this file now. Okay. You don't need to be able to read everything in this file. If you want to understand how to read it more, read our unit test quick start, because it explains some of the library we're using. Basically, we're creating what's called a test suite. So this is one of those lines in ece297 exercise. This is the intersection, functional intersection test suite. There's a constructor to set things up. There's a destructor to take things down. You don't really care about that much. This is what you really care about. Okay, so this test fixture says board setup, and I'm making a set of tests that are called intersection street segments. If you look at the ece297 exercise output, that's the one we've been failing. Okay, and we can see what it does. Okay, so what does it do? It makes a empty vector of street segment indices called expected. Then it actually puts 3 numbers in it. Okay, 7, 140, and 147. And then it basically calls your find street segments of intersection function. It calls it for intersection 13. It takes that, it sorts it. Sorted is a built-in STL function, C++ library function. So it sorts the vector that you returned, and it checks, is it equal to this vector here, the expected output. Okay, so what this is doing is we have figured out already that for intersection 13, it has 3 street segments that touch it. Their IDs are 7, 140, and 147. We put that in a vector, we call it expected. We call your function, and we check if the vector you return is the same as the vector that we expected, and if it is, you pass. And if it isn't the same, we print an error message, and we count it as 1. Does that make sense? I mean, inside the library, it actually has a counter. So it basically says 1 failed test. Do you understand? So it's kind of boilerplate. You're going to see this over and over again. Then we do it again. So we basically say, well, for intersection 34,000 and something, we expect these street segments. So we do another, we call you again, and we do another check. And we do this about, I don't know, 30 times. And we basically figure that, okay, if you got 30 of these right, that looks pretty good. We'll say that you passed this test. With other tests, once you submit that, we'll check other intersections, just to make sure you didn't just basically store all these ones in your code. Does that make sense? Why do you think, let me ask you a quick question. Why do you think we call this sorted function? So we call find street segments of intersection. Again, that's your function. We pass you an intersection ID. You're going to return us a vector. We want to check if it's equal to the vector that is correct. But before we do that, we sort your answer. Why? Do we need to do that? Yeah, what do you think? Yeah, so basically we're doing this to make sure that we accept any valid response from you. So actually writing tests is tricky. When we write the test in this course, we have to be very careful that the tests check the specification we give you and nothing else. Okay, they should not check that just because our code put these street segment IDs in a certain order that you put them in the same order, right? We didn't specify that, so we sort them, and now that guarantees that you'll pass no matter what. If you look at some of the other tests, you'll see there are tolerances, right? If we ask you to find the distance between 2 points, we don't check for an exact match, we check for it within some tolerance. So the idea of all of this is that any valid solution will pass our tests, and it actually takes a little more thinking to do that. And so occasionally we screw it up, right? In which case, if you ever think we did that, let us know. And you will get bonus marks and a chocolate bar, okay? All right, so that was the first test. In here, there's another test for intersections directly connected. Okay, so it's put in a new test fixture, and there's actually a third test for angle between segments, like find angle between segments. So, and that's it. If I go down to the bottom of the file, that's the end. Okay, so there's actually 3 subtests inside here. I actually only care about 1. So what I'm gonna do first is, let me go back. Okay, so I'm gonna click on, I think I actually have to zoom out a little. If I zoom in too much, I don't even have all my icons. Okay, so I'm gonna click on this makefile extension, and I'm gonna start building the program from inside the IDE. So first thing I wanna do is, I'm gonna be doing unit test debug. I'm debugging, I want to run the unit test through the debugger. Select that configuration. I have to say what program to build. okay? And the program I want to build is test libstreetmap, okay? I don't want to build my mapper. I want to build test libstreetmap because that's what I'm testing with the unit tests. And when I launch the debugger, I also want to launch that same program, test libstreetmap. So I've selected those three things. And now I can build my program. Okay, so I click on that, it's going to build. And that didn't do anything. So I'm going to, because it already has a build that's ready. So I'm just going to say clean it to get rid of the old compilation results so you can see this. And now I'm going to build it again. And still happy with it. Okay, whatever. Visual Studio, sometimes I have to clean it from the command line. So maybe I'll just type make clean here. Let's see. Okay, so now I've built this. I can just run it. So I'm just going to click this arrow and just run the program. So I'm not actually debugging it. I'm just running it from inside the IDE. And why did I do that? Why did the build fail? That's weird. Okay, let me try this again. Terminated with exit code that. Oh, okay. This is interesting. I think I must have accidentally hit something in one of the, it's actually not building, so I must have accidentally hit something in one of these files. So unit test util line 194. Did I? Okay. All right, so what I'm going to do then is I'm going to, let's see if I can just actually undo this. Oh, at M1 I did it? Thank you. Thank you. Let's see. Yes, I'm not trying to change anything yet. Okay, let's go back and do this again. Success. Thank you for noticing that. Okay, so, okay, so I'm just gonna run this first. And it basically is the same thing that I was getting from the command line before. So I just ran the unit tests. I just did it from inside the user interface. And it basically gives me a long sequence of output. The very first line is that there's a failure in that intersection street segment test. It crashed. And then I get a whole bunch of failures from the other two tests, which I haven't actually written yet. I haven't written those functions, so I've stubbed them out. I expect failures. I don't want to look at those failures over and over again. So I can just get rid of that code. So let me get rid of this right now. Okay, so this is all editable. It's in my project. I basically want this find intersections of street segments test, or find street segments of intersections test, but I don't want the other two right now. So I'm just going to delete them. So I get rid of all that code, and I'm going to bring up the Makefile tools again. I'm going to click build. Okay, so it's been rebuilt, and if I run this, I should now get just the one test that I want to focus on should be all that I get. And Visual Studio does this super annoying thing if it doesn't scroll to the bottom. So I just scroll to the bottom so I can see the most recent output, and it basically says it ran this test libstreetmap, and there's exactly one failure, which was a crash. Is everybody with me so far? So I've successfully brought over the unit test that was failing. I've gotten rid of the functions I don't want to test anymore. I'm focused in on what I need. So now I'm ready to debug. So first thing I'm going to do, so I'm just going to click on this little bug icon and launch the debugger. I'm not going to bother setting breakpoints or anything. I'm just going to run it. Okay, but I'm now running it through the debugger, and it tells me that a seg fault has happened, which is not a surprise, right? I know from debug check, I know from Valgrind, I have memory corruption, so I expected this. What can I do now? Okay, so I got a seg fault. It actually tells me where it is. I'm way down in this C++ standard library. Okay, a function called new allocator. All right, this is not going to be my bug, right? I should not, actually I have had students before who they write a program and it doesn't work and they will say, I think there's a compiler bug, or I think there's a bug in the standard library. That's not a good hypothesis, right? You should assume the code you wrote 10 minutes ago has a bug, not that the compiler has a bug. Compilers do actually occasionally have bugs, but they're rare. So I'm way down in the new code. That's not my problem. I need to know how I got here. So what can I do right now? Any ideas? Yeah, what do you think? Yeah, so I can look at the call stack. So the program's dead, but I can basically examine the crime scene. So I can't, I can't single step, I can't do any of that because it's already dead. But I can go over here to the call stack and I can see, okay, I was in this new allocator, that's not the problem. Where'd that got called by something else in the standard library. That got called by pushback of vector, that's closer, and that got called by this line that I already was worried about in load intersection street segments. Okay, so once again, we're back to, that helper function of load map is my problem. And I can actually see things though now. So I can see, if I look up here, I can see intersection is 1. If I hover over it, I should also see that. Yeah, so intersection is 1. I could see, well, how many segments were at that intersection? Maybe that's weird. No, it's 2. Doesn't seem weird. I can check how many intersections were there. I actually know there were about 190,000 in Toronto. So all these variables look okay. The street segment ID I was trying to push back was 0. That doesn't seem crazy, but it crashed. So again, I know it crashed on intersection 1. I crashed on this line. Now, I'm still not quite sure what to do. So I'm going to set a breakpoint. And I'm going to hit this red button to stop the debugger. And I'm going to immediately start it again. So I'll click on these makefile tools and launch the debugger again. But this time it stopped my breakpoint. So now the program's alive, I can control it. I can make it single step and so on. So I'm going to step through. Okay, so this function, okay, what does this step over do versus step into? Anybody know? So I got these 2 buttons at the top. One of them shows step over, the next one next to it says step into. And I'm on this line here. What do you think you want to do? Yeah. Yeah, so step into actually go in that, and I can watch what happens there. I didn't write that. Wow, I did, because you guys didn't write it. I'm confident in this code. This is in our library. So that's probably not the problem, right? If it was our library, it should post all over Piazza and calls to the chair for my head and all sorts of stuff. So it's not happening. It's probably not that. So in this case, step over is a better choice. So I'm going to step over, and I can, let's see, let me get the debug tools up here again. Okay, so what I just did there is I clicked on this little arrow with a bug to get the debug window pane up. So it's showing me up here interesting variables, so num intersections, etc. And I'm just going to step through this. Okay, so I push back something to intersection 0. I'm going through this loop for intersection 0, and I can see the number of street segments is 3. So I can basically watch interesting variables here. I can also hover over them and see what they are. So far, nothing looks weird. Like, these all look okay. I'm going to keep stepping over. Okay, so I'm going through those 3 intersections, or 3 street segments. So I should go from 0 to 2. Okay, I get a certain street segment ID. And go through this again. I get, so I'm at index 1 now. I get street segment ID of 109. That doesn't look crazy. I push it back, go through. I get another street segment ID, but also doesn't look crazy. Should be about 200,000 street segments in Toronto. I push it back. That was all good. Now I go back to the next intersection. So my intersection number is now 1. And I know this is the problematic one, so I'm going to watch really carefully. Okay, I get a street, it says there are 2 street segments that hit this. That looks okay. I'm looking at the first one, and I'm going to call this, and I crash. Okay, so that pushback is not working. So now you've got to kind of look at the code carefully. Like, you can't get in, I can't get any closer to this. Like I know it's intersection 1, I know all the other data looks okay, I know this pushback fails. So this is where you sometimes need a flash of inspiration. So I'm gonna ask, well, what is the size? Let me go back here so I can actually see the names. So there's this, I keep dying when I'm accessing, oops, let me just double click on this. Okay, so when I'm accessing this intersection street segment, I keep dying. Intersection street, whoops, that's not gonna work. Okay, intersection street segments. I'm gonna ask how big is this vector? Okay, if I do this, it's gonna tell me the size of the first dimension of that vector. And basically what I'm doing in this watch window, I can type in variables or I can type in even expressions. So here I typed in an expression. I want you to call that member function. It says there's only one entry in this vector. I'm trying to access entry 1, it's gonna crash. So I found my root cause. The question is, why is there only one entry in this vector? And now I need to look very closely at the code to see why is that the case, because I didn't expect that to be the case, but clearly I did something wrong. So what do you think has happened? Why is there only one entry there? Yeah.
You push back just a single vector.
Yeah, so my bug is actually here. So I basically say, first I have a global variable. Let's go back to this global variable. Okay, so this global variable is a vector of vectors. Global variables are actually constructed. They're constructed before main is called. So they actually get set up before main. I didn't give any arguments to the constructor, so it'll be default constructed. What does that mean? It's a size 0 vector, okay? It's a 2D vector, but the first dimension is size 0. There's nothing in it. That's what I'm gonna get. Then when I go up here, I ask how many intersections are there, and then I basically say, take that vector, which currently has 0 things in it, and push back one vector. And that just creates the first entry. Okay, so this isn't gonna work. Then down here, I basically start accessing entries for any intersection I want, but I can't create things with the square bracket operator. It's not allowed with the vector. So I shouldn't have done this. So now I know the problem. How do I fix it? So there's 2 ways I could fix this, one of which you may not know. So how would you fix this? What do you think? Yeah. So you can say it a little bit louder. So saying in here, put a pushback. Yeah, and that'll work. Okay, so before I try to put something into an entry, I do a pushback right here. So let me just actually type that. So if I went intersection, street segments, I wonder if this will actually autocomplete right now. Nope. So again, if I put in that street segment IDs, it'll work because I'll create the new entry before I try to use it. So that's fine. Obviously, I have to fix that. I didn't quite finish it. So that is one way to do it. Undo that. There's another way to do it, and I'm going to show you that now, just because it's useful to know about. So let's see. Okay, so I told you you're going to go to C++ reference guides a lot. So if I go to cplusreference.com and I look at vector, okay, I'm using vector, I want to know what's in it, and I scroll down here, I get to its member functions. Okay, and if I look through its member functions, you would have to read it slower than this, but there is a member function called, let's see, where is it? Resize, there it is. Okay, so there's a member function called resize, and it says changes the numbers of elements stored. So I'm going to click on that one, and let's see what it does. That's the example, so that might be a good one to do it. But basically, it resizes the container to contain count elements. All right, so basically, pushback is convenient when you got a vector and you're trying to grow it. But if I already know exactly how big I want it to be, it can be easier just to call resize to say, look, I need 190,000 entries. So I can just do that once. So that's pretty common, so they made a member function to do it. It'll actually be marginally more efficient than calling pushback because you'll get no copying or anything. Doesn't matter much, but it's also just kind of convenient in this case. So when you know the size of a vector, you can just ask for that size right away. So I'm going to go back here, and so what I'm going to do is instead of doing the pushback, I'm just going to fix this. So I'm going to go intersection street segment dot resize, and I need to say how many elements, so it should be num intersections. Okay, and assuming that I've coded that correctly, I'm going to go back now to my make file. I'm going to build it. I feel lucky. I'm going to just actually run it. I'm not even going to run it through the debugger, so I just click the arrow. And let me make this bigger. And it says success. One test passed. Okay, so the bug's gone. Didn't crash. In fact, it passed all my tests. It just works now. So I'm done with that. Let me ask you one more question. So I set this breakpoint here. Let's say I could set a breakpoint down here if I was debugging and I needed to look. But let's say that the code crashed on intersection 187,000. Okay, so if it crashed there, I want a breakpoint in this for loop because I want to look at what happens for intersection 187,000. But I might not want a single step through or hit continue 187,000 times. What do you do in that case? Does anybody know? Yeah. Yeah, that's exactly right. So if I right click on this breakpoint, I can say edit breakpoint, and you can type in a condition. It can be any legal C++ expression. So I could basically say intersection, yeah, so I called it intersection equals 187,000. And hit enter. Okay, so that breakpoint now will only fire if it's at intersection 187,000. And I could even show you that. Let's see, I'm gonna get rid of this breakpoint. So I'm gonna run it by clicking on the debug icon. And I got a seg fault. Why did I get a seg fault? That's bizarre. Oh, actually I got a seg fault because I must have done, let's see, what did I do wrong there? Line 55 has a seg fault. Num intersection street segments dot resize, num intersections, line 55 has a seg fault. I don't know what I've done there. So interesting. Okay, so I will mess around with that after because I probably hit like a stray character, but you can set conditional breakpoints. So, and they can be useful. Okay, so that's it for the demo. Again, I went through that pretty carefully so that you can actually go back and look at this if you need to know, hey, what command do I do to debug this? You're going to wind up doing this a bunch in this course. Okay, so last few minutes, 20 minutes, we're going to do a team debugging activity. So you're going to debug a simple program in an online IDE. The program sorts its command line arguments. So the program name is argsort. Dot means, do you guys know what dot means when I type in a command prompt like this? Does everybody know what that means? Not sure? Okay, dot means current directory. So all this means is the program argsort in the current directory. And then we're passing this program some command line options, in this case, integers. So we're passing it 6, 1, and 3. All this program is supposed to do is sort whatever its input arguments were and print them out again. Okay, so if I call argsort with these 1, 2, 3, 4, 5 numbers, it should sort them and print them out again. Okay, this is the code that you're going to debug. It breaks down into two pieces. Here's your main function, and then there's a sorting function that it's using. Okay. First of all, do you guys know what this is? Do you know what argc and argv are? Okay, so argc and argv are how command line options are passed to C and C++ programs. argc is the number of words that are on the command line. So in this case, argc would be 4, okay, because it's the name of the program, and then 3 arguments. In this case, argc would be 6. argv is an array of C-style character strings. Remember, C doesn't have a string type, it has a character star. Okay, so argv is an array from 0 to argc minus 1, argument count, so of the strings, right, the words. So that's all that is. What is this program doing? It's basically making a vector where it's going through these argv arguments, these C strings, putting them into this vector of integers. So that's what this first part is supposed to do. It calls this shell sort function to sort them. What is shell sort? It's like quick sort, but it divides things into 3 pieces. So that quick sort was kind of hard to read, shell sort is extra hard to read, okay? And the person who wrote this, used unfortunately short variable names and didn't comment. Don't do that, it's bad code style, but that makes it a little harder to debug. Okay, after it's sorted, the program prints it out. So that's what it's trying to do, so these 3 things. It doesn't work, okay? There are bugs in this program. So if you run it, yeah, it's not gonna give the right answer, okay? But this is what your inputs would be. So for this input, you'll get argc is 4, and you'll get these 4 character strings. Okay, so in the remaining time, with your team, go to this web address, https://bit.ly/2fupl, that's an L, UN. Yeah, I'm going to show you what it looks like. So this is it's an online IDE with a debugger. Okay, how many people, so type it in, humor me here, it's a nice little debugger. It's, most C and C++ debugging is done with a debugger called GDB. That's what VS Code's talking to, that's what NetBeans is talking to, that's what this online debugger is talking to. So they're all actually talking the same debugger, they just have slightly different user interfaces. All right, so did you guys manage to capture that link, or should I bring it up again? This is what the IDE looks like. How many people need me to bring the link back up? Okay, all right, this is what your online IDE looks like. I was gonna quickly show you how to work with this. So you can see the program, right? There's shell sort, there's main, you can run it. Okay, so I just ran it, and basically nothing came out, no output. So I'm gonna click on debug. And the debug is basically just another view of the debugger. Right now I've got this, I've clicked on this right side, so it says debug console. If I click on the left side here, I see my input. So the command line that's being sent in right now is just 3 numbers, 6, 1, and 3. That's the input. So I'm gonna click back on the debug console, and I can say, I can basically say start running. And now I can set breakpoints, I can single step. So basically I have single step controls down here, I have breakpoints up here, I can see variables over here. The one thing that's a bit unusual in this is I can look at variables. Let's see, let's step over. I can basically type expressions that I want to watch. So I could say I want to watch I, but they won't show up until I step. Okay, so don't be confused by that. The reason they don't still show up until you step is that it has to actually, basically doesn't update until it sends a command to the debugger to go 1 step forward, and then you'll see the expression update. So if you type, this confused me for a little while. I type an expression and it doesn't show up until you step once. Okay, so what I want you to do is basically try to debug this program. It doesn't print anything, right? We just showed that, but I'm sending in 3 numbers. Try to use the techniques we talked about. How do you get the most information the fastest for this? So one technique would be, I'm going to read all the code really carefully. That is not the most productive technique, because the shell sort and so on are a bit messy. And if I give you 1,000 lines of code instead of 100, that technique doesn't work well at all. So how can you use things like the wolf fence method to try to rapidly zoom in on where the problem might be so you can find and fix it fast. Okay, so I'm gonna let you guys try to work on that. And in case you didn't get it, there's the web address. Yeah. For a second. Okay, how many people managed to debug it? Debugged, you guys debugged it? You guys debugged it? Okay, so if you successfully debugged it, come get a chocolate bar afterwards and I trust you, okay? Also, if you, I do a good job of talking to people today, we spent a lot anyway, so answer a bunch of questions, if some questions, come up and grab a chocolate bar as well. Let's see, so actually I just talked to you guys, so maybe you'll just repeat for me, what approach did you use? Right? Yes, that's a very good approach. So you found that you didn't sit there reading all this nasty code, particularly this nasty sorting function. You used the wolf fence method. You determined that in fact your vector is never properly loaded, so the bug is way earlier. You fixed that. A couple of bugs in how it was loaded, you fixed those, and that worked. So yeah, so that is intended to teach you, don't just gotta read all the code. You gotta, if you can divide down, figure out, hey, the problem occurs here, or in this narrow range, now you're really focused, and it can save you a lot of time. And that time savings gets bigger and bigger as the program gets bigger. And I'm trying to, okay, anyway, I don't know how to like duplicate the screen right now. So yeah, so carefully reading all the code is not the most efficient approach. You do have to be able to read code. Like once you get back to a small region, you still have to figure it out. And it's not a bad approach once you have a general idea where the problem is. Take a quick look at the code, maybe read it for a few minutes, see if you see the problem. But if you don't, start dividing down where is the issue. Last year, there was a student who posted on Piazza on like a long weekend, a post saying, I've been staring at this code for 7 hours. I can't figure it out. What's the problem? Please help me. And I did give him some hints, but I also said, like, you should never stare at code for 7 hours. Like, this is not a good approach. Fire up the debugger. I don't know how long he was going to look at this code before he broke down and used the debugger, but it was clearly more than 7 hours. So don't do that. It should be more like, I looked at the code for like 4 minutes. Now I'm firing up the debugger. And yeah, so you use the wolf fence method, and then probably you started forming hypotheses of, okay, looks like this vector's never loaded. Let's dig into that deeply. Okay, so have a good weekend, and hopefully these skills will be useful to you. Next tutorial, next week we'll be talking about code style. So which you want to think about as well for milestone 1. So another thing your TA is going to grade you on, good code style. I mentioned a few things to watch for. We'll talk about more next week, and you can incorporate that into your solution. Okay, so have a good weekend. And like I said, if you basically got it working, come up, grab a chocolate bar. If you answer some questions, grab one.